Hi, and welcome to our presentation on minerals and rocks. So you should write with the Roman numeral 1 up at the top of your paper. 1. Minerals and rocks. Pretty easy. This is going to just basically lay down the foundation for us to figure out why the rocks in the earth act the way they do, and hopefully it'll give you some kind of idea about the rocks you see in your everyday life. So let's get on it. Minerals, an important term. They're naturally forming, meaning not created by humans. Non-organic, meaning not based on something that was previously alive, say the decomposed plant or animal matter of ancient times. Solids, so not liquids, not gases, made up of one particular element or compound. And when we're talking about an element, we're talking about a single type of atom. So it could be something like gold, which you see before you, which is, gold is an element. It's the most elemental form of matter, or a compound, meaning a combination of different elements, like say salt, which is a mixture of potassium and sodium. A compound is a set of two or more elements that are joined to each other in a consistent formula. A subset of minerals are crystals, like say salt or like quartz. And what sets these minerals apart from other minerals are that the atoms line up in near perfect patterns in a three-dimensional, in 3 dimensions. So diamonds, for instance, are another crystal. Although diamonds are very expensive, whereas those like quartz and salt, for instance, not expensive. So just because something's a crystal doesn't mean it's incredibly valuable. But it does mean that it follows a regular pattern on the atomic level, and most of the time that regular pattern on the atomic level, it appears also as some kind of regular pattern that we can see with the eye, on a larger scale, like this quartz rock that you see in front of you. So, a rock is a solid made up of one or more minerals. So, to get this straight, all crystals are minerals, but some minerals are not crystals. And all minerals are rocks, but many rocks are made up of more than one type of mineral. So if you got, if there was some kind of rock in which pieces of gold were fused with pieces of sand. Now I don't think that rock exists, but if it did, that would be a rock because it would be made up of two or more minerals, of 2 minerals. And rocks make up the solid part of the earth. That's no surprise. But a rock doesn't have to be a big boulder. It could be just the ground that we walk on. Dirt is in fact really, really tiny rocks, as with sand. Rocks, the fun thing about rocks is that they change. They change from one form to another by different processes, and these processes usually have to do with heat. The heat within the earth can heat up rocks and change it. Pressure, the forces within the earth, as the plates of the earth move, they can crush certain types of rocks and change them. And we'll talk more about the moving plates later on. Rocks can be broken down by the weather and turned into tiny little fragments called sediment that then can get pressed together and compacted and either chemically or just physically be smushed together into a new different type of rock. So we'll be talking about the rock cycle as we go on. But right now, we're just going to lay out some of the characteristics of the three different types of rocks. And those three types are igneous, sedimentary, and metamorphic. Starting with igneous. Igneous rocks, one is pumice, if any of you use those little scratchy stones with a lot of air holes in them, say you're in the shower to exfoliate. These igneous rocks, they form when melted rock, which is called magma when it's inside the earth, and lava when it's extruded out onto the earth's surface. When this melted rock cools, it becomes igneous rock. Igneous rock comes in a lot of different kinds. And most obviously, or most familiarly, you see, the black sands. The black kind of air bubbly rock. On beaches, on lava flows in certain places. But it can look different depending on the conditions and depending on what type of rock is in the magma to begin with. And the different types of minerals melt or re-solidify at different temperatures. So as the magma cools and the different types of minerals in it do begin to solidify, when they do that at the different temperatures, you get what you see before you, which is a kind of strange, patterned, spotty, splotchy rock. You also have sedimentary rock, and this is made up of small fragments or sediments of other rocks, minerals, and organic matter that has been crushed or weathered down into tiny little bits. Then these rocks, these tiny little sediments, they get in rivers that flow into the ocean, and they settle down usually upon the ocean floor, where the huge pressures of future sediments that land on top of it, and the great pressure caused by all that water in the first place, presses down upon it and creates a solid rock out of what had been, to us, just sand or dirt and tiny little pieces of rock that were flowing in rivers. And there are different types of this, mudstone, siltstone, limestone, sandstone, for instance, as you can see. Sedimentary rock is also, it can carry a lot of different chunks of things, different minerals, fossils. A lot of the time when you look at a rock that has a bunch of shells in it, fossilized seashells, that's going to be something like sandstone because it formed at the bottom of the ocean, and mixed in with it are all the dead shells or bodies of lots of ocean creatures. So here again is your rock cycle. Igneous rock can turn to metamorphic rock due to heat and pressure. It can turn to sedimentary rock when it's weathered down and turned into small sediments, and or it can turn into magma when it's put under great heat, and then from magma it turns back into maybe a different type of igneous rock. Sedimentary rock likewise can due to incredible heat, turn into magma and then to igneous rock, or just lesser heat potentially could turn it into metamorphic rock. Metamorphic rock, when it's weathered, turns back into sedimentary rock, and when it's entirely melted by the heat of the earth, it can turn back into igneous rock. So the cycle continues.